One, we know that the positive terminal of the battery is here and the negative is here. Okay, and so if you think of this wire, this little strip of wire is having an electric potential of +9, and this one is having an electric potential of 0. Then at the resistor, the positive terminal is here, the negative terminal is here, and what's the voltage across the resistor? Yep, 9. And so what's the direction of the current? Yep, down. And now to solve for the magnitude of the current, 9 is equal to I times 20. So I is equal to 9 over 20, which is 0.45 amps. And so what's the direction of the current at the battery? Or what's the current at the battery? Yep, that's right. So we figured out that the current in this circuit is 0.45 amps going counterclockwise. So here it has to be 0.45 amps clockwise, counterclockwise. The way I drew it, whatever that is. Okay, so here's general interest application of this stuff. As a human being, you are a resistor, like you resist electric current flow, and your resistance is pretty high. Most of that resistance has to do with your skin, and so there's not too much you can do to lower your resistance. And so if you put yourself in, you touch some electrical thing, touch the two socket terminals or whatever at an outlet, you have a resistance of about 10,000 ohms. Okay, so you can think of yourself as you can think of yourself in a circuit like this, where this resistance is 10,000 ohms. Okay, that's you. Recognize yourself? And so then the question is, what would the voltage have to be? I mentioned before that danger of like electrocution starts at about 0.1 amps. So what would the voltage have to be for like an electrocution danger? Electrocution risk. And electrocution risk starts at about 0.1 amps. Well, you could do this the same way. We'll call this, so we know this is the positive and this is the negative, right? We don't know what this is. We'll just call it V for now, okay? So by that same thinking that we did in those last two problems, we know that this is the positive terminal, this is the negative terminal, and this resistor has a voltage V. okay? And so we know that the current direction is this way, right? We also know that the magnitude of our current, that was given in this problem. We want to see what V has to be for the current to be 0.1 amps. And so now Ohm's law says V is equal to 0.1 times 10,000. And so V has to be about, not 10,000, about 1,000 volts. Okay, so 1,000 volts. Is there anything that we come in contact with normally that's 1,000 volts? Do you know what wall outlet voltage is? It's about 120. So, so the wall outlet should be pretty far from putting you at an electrocution danger. Like you could lick that all you wanted, you wouldn't have any problem. In Europe, outlets are 240, so that's a little worse, but you still should be safe. So. Yeah, well, all water does, you know, it's funny. Water is a conductor, is a insulator actually. Like pure water is an insulator. So pure water would only keep electricity from hurting you. But you never really encounter pure water. Usually there's some kind of electrolytes in there, and those will make electricity flow. And so all that is, when you have water that conducts electricity, all it means is that electricity can, it's a conductor, and so electricity can easily flow from anywhere in the water to anywhere else in the water. No, it doesn't increase or decrease. It's just the same thing as, you know, having an extra wire going from one part of the water to where you are in the water.
Now, if you stick a piece of metal in the socket, would that be a different?
Nope, because that's just, again, just a conductor. So that's just a way to, the reason metal makes it more likely that you'll get an electric shock is just it's hard to fit your finger in there, you know? So if you took a piece of copper and plugged one end in there and you were holding the other end, then you're guaranteed to get a shock. But the shock is not going to be enough to kill you, you know? It'll only make you stronger, apparently, from what I understand. Any questions about any of this? Okay, let's stop there.